In this video, we're going to be talking about multiplying fractions. Now, I know sometimes this can be confusing to kids because when they multiply, they're used to the product increasing, which only makes sense. So, like if we're talking about 1 times 2 is going to equal 2. And if you think of it as a word problem, you know, mom's packing my lunch and she gave me 1 bag with 2 cookies in it. Or if we go ahead and continue 1 times 3, we're looking at that as the 1 baggie for our lunch with 3 cookies in it. And then we'll continue on 1 times 4 equals 4. 1 baggie with 4 cookies. And we'll stop there. I don't think I can handle any more cookies. But if we're looking at it with fractions, you're still following that pattern that they're used to seeing. But if you think of it 1 times a half, you're not getting that whole cookie. You're only getting part of that cookie. So if you think of it that way and picture that cookie that mom is packing in the baggie, you're only going to be getting half of it. So it only makes sense that that number is smaller. All right, and we're going to continue on talking about several different strategies that students can use to multiply fractions. Before I go ahead and continue on with this slide, I just want to tell parents that in 5th grade, students are only expected to multiply a fraction by a whole number, so we don't need to get into the fractions times fractions, so just a fraction times a whole number. So now let's think about it again. Let's picture it in a different way. I have this equation right here, 1/3 times 6, or you can think of it as 1/3 of 6. So if you think about your fraction is actually telling you how many parts the whole's been broken into and then how many of the parts you're going to take. So if we look at our 6 circles over here, we're going to think about we need to divide that 6 into groups of 3. So we can see this here as one group, here's the second group, and here's the third group. So if we can see the 1/3 part of the equation is actually going to be 2. So 1/3 times 6 will equal 2. Now we can continue on and use this and do 2/3 times 6, which means we'll have to look at the 2 parts of the 3 that we had broken into. So we can see that 2/3 of the 6 is 1, 2, 3, 4, is those 4 circles. As you know, multiplication is repeated addition, so we can also look at multiplication of fractions and look at it as repeated addition. As you can see here, I have a pictorial model, the 3 circles. Don't judge me on my drawing. And we have each circle divided into 3 parts, and I colored in 1 of the 3, which is what our fraction told us, 1 out of the 3 parts of the whole. So students can also sit here and they can either count up these, which means 5 of the thirds is what the answer is going to be, or they can look at it as a repeated addition problem, do 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. And then you would just go ahead and add those up like you normally would with fractions, and we're just going to count up, we're going to add up those numerators, which there's 5 of them. And then since we didn't change how many parts we broke that whole into, it is still out of thirds. So 5 times 1/3 equals 5/3. Now we can leave our product or the answer 5/3 in an improper fraction meaning that the numerator is larger than the denominator, or we can change it to a mixed fraction. So as you can see here below the blue line, I've redrawn our circles and I've just taken these parts and I've just filled in a whole circle until it was all full and then did another circle. So as we can see, we have one whole circle that's filled in and then 2/3 of another one. So your 5/3 will, and if you mix it or change it to a mixed number, is actually going to be 1 whole and 2/3. Okay, so we talked about the idea of multiplication being repeated addition. So if you also think about it, it's once you're looking at your products like 2 times 1 equals 2, 2 times 2 equals, 2 times 1 equals 2, 2 times 2 equals 4, 2 times 3 equals 6, and so on and so on, and you're looking at your product or the answer, and it's like skip counting, 2, 4, 6, 8. So if we think of it in that way, then we can also use the number line to do our multiplication of a whole number by the fraction. So I have an example word problem here. It is 3 times 1/4. I'm sorry, that wasn't a word problem. It's just a straight up equation. I've got a number line drawn out from 0 to 1. And then you can see I segmented it into 4 parts. Now down here at the bottom, you can see I went ahead and wrote the fractions. So 0 can really be looked at as 0/4. So that means we've taking 0 parts of the 4 parts that we created, and then as you can see here with the 1 is the same thing, or it's equivalent to 4/4. So we can start from the very beginning at 0/4 or 0, and we're going to skip 1/4 of the way, and we'll do that 3 times, and then we should get to our answer. So 1 hop, 2 hops, 3 hops. So it looks like our answer right here should be 3/4. And then we could always check that again with our repeated addition that we did previously. We'll add those up, and that also gives us 3/4. Now you may remember when your child started multiplication, they may have used a multiplication array, and as we can see here, like 3 times 2, we're talking about 3 rows of 2. Well, we're going to also kind of use this idea to create area models when we're doing a whole number times a fraction. Okay, so now let's look at it with 4 times a half. So we'll look at this 1 square here is 1 unit. So I'm going to need 4 because I'm going to have a 4 by 1/2, just like over here I had 3 by 2. So we'll have 4 units. But this time we only need a half of each of those. And let me color in that half there of each of these. And so as we can see, we'll look at it here, and we've got 1, 2, 3, 4. 4 of each of those halves. I'm going to make this a little bit longer here so you can separate them out. Alright, so again, like I said, you're going to have 4 of the halves. So 4/2. Now again, if you want to look at it, the students can draw out the rectangle to fill in to change that improper fraction to a mixed number. And this one, I'll get the 2 halves they'll fill in, and then the next square will have the other 2 halves. So your answer for this can be 4 halves or 2. Now let's look at just one more area model just to be clear. So we have the problem here, 3/5 times 5. So I went ahead and drew out my units, and I tried to extend those lines out so you can see the 5 different parts. First part, second part, 3, the 5 that I'm multiplying, the 5 units. And then I broke each unit into 5 parts, coloring in 1/3 of each. So if we look at this, I have got 3, 6, 9, 12, 15. I have 15 of those boxes out of the fifths, or 3 holes. Now, after we've gone through all these different strategies and we've practiced these in class, we're hoping that the kids can start visualizing or seeing or grasp the understanding of what they're doing when they're multiplying their fraction times a whole number. So the very last step should be the algorithm that we're looking at. So, and you may be like, why didn't you try this? It's kind of the quick trick. It's the way I learned. Well, we're wanting the kids to conceptually understand where that answer is coming from. So once they understand that, then yes, we can go ahead and move to a more efficient way of solving by doing the algorithm. So if you look at this 1/3 times 7, And we can rewrite it as 1 times 7 here over the 3, which would give us 7/3. Now, if we use the picture model with the 7 circles, then splitting those circles into 3 parts and coloring one of each, and you count that up and you have 1, 2, 3, 4, 5, 6, 7, 7/3, so that we checked that our answer is correct. And then again, if you want to make this improper fraction into a mixed number, then you can always go back in and draw those circles into the thirds and bringing them over. So 3 of those circles here will fill up one whole circle, and then another, I guess I should have drawn this better, another of the 3 circles will fill up the next one. And then we're going to need one more circle here, divided into 3, to get that one leftover one, so that we can see that this is also equal to 2 1/3.